Hello, welcome. In this short video, let us look at one of the basic inequalities for complex numbers. It is given two complex numbers z1 and z2. We want to show that the square of the difference, that is z1, absolute value of z1 minus absolute value of z2 whole square, is always less than or equal to the absolute value of z1 plus z2 whole square, which is in turn always less than or equal to the square of the sum of z1, absolute value of z1 plus absolute value of z2. So we want to prove this inequality. Let us look at the proof. Given a number x that belongs to the set of real numbers and a value a which belongs to set of positive real numbers, then the inequality, that is absolute value of x less than a, basically means that the value of x lies within the interval minus a to plus a. In other words, x belongs to the closed interval minus a, plus a. For the two complex numbers z1 and z2, we know the following inequality, that is z1 multiplied by z2 conjugate plus z1 conjugate multiplied by z2. Then the absolute value of this sum is always less than or equal to 2 times the absolute value of the product z1 and z2. So now we can easily compare this inequality with this inequality of x. The absolute value of x is less than or equal to a. Therefore, the value of this sum lies in the interval minus 2 times z1 into z2 less than or equal to the sum z1 into z2 star plus z1 star into z2, which is always less than 2 times z1, the absolute value of the product z1 into z2. This is true because this absolute value is always a positive real number, that is, this absolute value z1 into z2 always belongs to the set of positive real numbers, and this sum, that is the sum of z1 multiplied by z2 conjugate plus z1 conjugate multiplied by z2, is basically a real value because the second term is a conjugate of the first term. Therefore this inequality is valid. Now starting with the left one, we can clearly see that z1 z2 conjugate plus z1 conjugate z2 is always greater than or equal to minus 2 times the absolute value of the product z1 into z2. Now adding the terms z1, the absolute value of z1 square plus absolute value of z2 square on both sides, we get is greater than or equal to the sum of the absolute value of z1 square plus and the absolute value of z2 square. And then we have minus 2 times the absolute value of z1 into z2. The sum on the left side can be easily written as z1 plus z2 multiplied by z1 plus z2 conjugate. And the sum on the right side can be written as a minus b whole square, where a is absolute value of z1 and b is absolute value of z2. So this is absolute value of z1 minus absolute value of z2 whole square. This is true because the absolute value of the product z1 into z2 is equal to the product of absolute values of z1 and z2. So therefore z1 plus z2, absolute value of z1 plus z2 whole square, is always greater than the square of the difference z1 minus absolute value of z1 minus absolute value of z2. And by using the right hand side of this inequality, we know that the sum z1 z2 conjugate plus z1 conjugate z2 is always less than or equal to 2 times the absolute value of the product z1 and z2. Now again, by adding the sum of these squares of the absolute values on both sides, we can clearly see that it is equal to z1 absolute value of z1 square plus absolute value of z2 square plus z1 z2 conjugate plus z1 conjugate into z2 is always less than z1 absolute value squared plus absolute value of z2 squared plus 2 times absolute value of the product z1 and z2. Now the left hand side is clearly equal to z1 plus z2 absolute value of z1 plus z2 squared, and it is always less than or equal to a plus b whole square, where a is absolute value of z1 and b is absolute value of z2. So by using these two inequalities, we can clearly see that the square of the difference absolute value of z1 and absolute value of z2 whole square is always less than the absolute value of the square of the absolute value of the sum z1 and z2, and which is in turn always less than or equal to absolute value of z1 plus absolute value of z2 whole squared. Thanks for watching.